All right, Huskies, welcome back. Our last lesson of this very large unit. So great job so far. I hope you guys are staying on top of your videos and your notes. Definitely a great way to get your grade up is to get these notes filled out. All right, so the last unit, the last lesson is isosceles and equilateral triangles. Okay, so we're first going to talk about isosceles triangles. Right? This fancy word, isosceles, has at least two congruent sides. The parts of an isosceles triangle have special names. The two congruent sides are called the legs. Of the isosceles triangle. I'll try to abbreviate. I know there's not a lot of room. So these are called the legs. The legs are congruent. Okay? And then the angle with the sides that are the legs, so the angle in between is 1, which is called the vertex angle. Okay? So vertex angle. Okay, and I made like a little angle sign. The side of the triangle opposite of the vertex is called the base. All right? So this is called the vertex. Right here, angle 1. And then across the way is called the base. All right, the two angles formed by the base and the congruent sides are called the base angles. So the ones that are attached to the base segment are called the base angles. So 2 and 3 are called base angles. So we know as teachers, if we're filling it out, we are making sure to identify the triangle, putting in the necessary information. All right, now let's talk about this theorem, okay? So, isosceles triangle theorem. Two sides of the triangle are congruent. Then the angles opposite those sides are congruent. All right, so I have these are my legs, okay? That means that those two sides are congruent. So, therefore, the angles that are opposite. So, because of this angle, angle 1, and then opposite, and angle 2. Are now congruent. Okay, so it's flip-flopped. So kind of draw arrows so then you know that that angle goes with this base angle. So this line goes with angle 1. And this line goes with angle 2. Okay? The converse of isosceles triangle theorem, if two angles of a triangle are congruent, then the sides are opposite. So the same idea, but now just written differently, okay? So angle 1 and angle 2 are congruent. Therefore, angle 1, what's the opposite of that? Goes with FE. And then angle 2, I'm going to draw an arrow. Angle 2 goes with DE, okay? So we can use them interchangeably when we have that necessary information. And that comes in handy quite often. All right, so name two unmarked congruent angles and name two unmarked congruent segments. All right, so I'm going to write them separately because we're talking about two separate things. So when we're talking about two unmarked congruent angles, I'm going to be looking at the triangle that is ABC because the sides are congruent. So because these sides are congruent, therefore the angles that are opposite are congruent. So therefore angle C is congruent to angle B. All right, because AC is congruent to AB. So because of the sides, those angles are congruent. Now let's talk about the other triangle that we have the angle information. So D and C, and A is at the top, okay? Because D is congruent to C, we now talk about the opposite segments. Therefore, AD is congruent to AC. And there we go. All right, go back to A for me real quick. I apologize. Because these angles are together, we had to be a little bit more specific instead of just writing angle C, which is that middle letter. So we have to write ACB, which is talking about this angle right here. We don't want to say C because that would mean that whole thing. All right, so sorry, we got to be a little bit picky. All right, now we are going to talk about the guided practice. All right, so let me bring this over. and talk about these. All right, so we've got kind of a kite situation. So we want to look at the big triangle. So we want to talk about congruent angles. So we've got this one right here. And it has those angles that are congruent. So those sides are congruent. And we're talking about that triangle. So because that is opposite, so I want you guys to figure out what angles are therefore then congruent. So I'll kind of give you a diagram. So because this side, therefore this angle. Okay, how would we write that down? Okay, and because of this side, we have this angle. Okay, so write those down and report back. All right, so the G and the J are switched, and the F is the same angle for both right there. So FGJ, so that one, FGJ is congruent to FJG. Perfect. It's really important you guys are writing this down correctly so then we don't have any mistakes. All right, the next one. So because I'm going to redraw this so then I can see it. So I have H, G, and J, and I have these angles. So I need to think about what segments are opposite of that and how is that congruent. So write down those segments and find out their congruency. So GH is congruent to JH. Okay, again, the H's are at the end because it's the same angle. All right, now that we talked about isosceles, now we're going to talk about equilateral. All right, so equilateral triangle. A triangle is equilateral if and only if it's equal angular, which means the angles are congruent. Okay, so A, B, and C are congruent. Therefore, all the sides are congruent. All right. And if each angle of an equilateral triangle measures 60 degrees, okay? And why is that? Why is each angle of an equilateral triangle measure 60 degrees? That's a given. Why is that? Well, every triangle we know adds up to 180. Therefore, 180 divided by 3 is 60. Therefore, an equilateral triangle has to have 60-degree angles because all angles are congruent. There we go. So find each measure. So if angle X is 60 degrees, and then I have angle 8 and I have side 8 and side 8. So isosceles says you have to have at least 2 of something. But in this situation, well, let's think about this. Because of 8 and 8, that means that the opposite angles are congruent. And if these are congruent, that would mean, all right, well, 60 plus 2x equals 180. 2x equals 120, and then x would equal 60. So because the third angle is 60 degrees, that means that these two are also 60 degrees. Okay, so it looked like an isosceles, but it was actually an equilateral. All right, well, now that we proved that angle Y, Z, and X are all 60 degrees, therefore, that means that YZ has to be 8 inches like the other two segments. Okay, based on our theorem about equilateral triangles. All right, now I want you guys to try this guided practice. What information do you know? Is it an isosceles? Is it an equilateral? What do we know? All right, so this is an isosceles because these two are congruent. They have little dashes, which therefore means that the opposite sides are congruent. So therefore, PN is also 11 centimeters. All right. Now to find angle M, I need to think about this. Well, angle M and P are the same. So that means I have 2x plus, what's the third angle? 120, which equals 180. Well, this looks very similar to what's above, but this is isosceles triangle. So I'm going to subtract 120 to both sides. I have 60, and then x equals 30 degrees. So angle M is 30 degrees, and angle P is 30 degrees because they have to be the same. Right? So looking at a triangle and seeing what information they gave you and going from there. All right, so these are getting a little bit more complicated, and then we are almost done, folks. So for this one, 2x and 2x, that means they are the same. Wow! And if you notice, this side and this side are congruent. Therefore, this angle and this angle, remember the opposites, are the same. So therefore, this is also 2x. Well, now that we've proven that they're equal angular, meaning that all the angles are the same, now we know that BC is also congruent to the other two sides. Whoa, lots of info for that one. Okay, so now we can solve it and go from there. So if you want to get a little bit more detailed, AB equals BC because of equilateral triangles. Okay, so AB is 3, BC is 4y minus 5, and solve. Opposite of minusing 5 is adding 5, so that's 8. 4y, and then I divide 4 to both sides, and y equals 2. Okay, and then I can realize if it's equal angular, it's an equilateral triangle, therefore the angles are all worth 60 degrees. So I have 2x equals 60, divide 2 to both sides, and x equals 30 degrees for each one, because 2 times 30 is 60. All right. So find the value of each variable for the next one. Okay, so again, the same type of idea. These two, they both have a dash, so that means that they're equal to each other. So I can make the equations equal to each other. So those are the legs of the isosceles triangle. I'm going to solve, so I'm going to bring the 2y over, add this 2. So I subtracted 2y to both sides. Okay, then I can add 2 to the right, and I have 2y equals 4. Divide 2 to both sides. Add some more color, and y equals 2 again. My. Lots of equaling 2. Lucky. All right, so this is that's my vertex. And then I have this angle and this angle that are congruent. Now, I don't know anything about the bottom, so I can't prove that 6x plus 8 equals 80. I can't prove that. But what I do know is that these two angles are congruent to each other, okay? And I can use that with the 80, okay? I can use that with the 80. So I have 6x plus 8, and I have 2 of those angles, so I'm going to write both of them down. And then I'm going to add 80 because that's my third. That is my third angle, and that all equals 180. And then what I can do is combine like terms. How many x's do I have? I have 12 x's. And then I can combine my constants. So 80 plus 16 is 96, which equals 180. All right, so from here, I'm going to subtract 96 and get 84. Then opposite of multiplying, dividing, and x equals 7. So y equals 2 and x equals 7 for this isosceles triangle. All right, so thank you so much for joining me on this lesson, on lesson 6. And hopefully you guys are doing well. Please ask questions in class and get going on that homework. Have a great day. Bye.